I'm Peter Sommerlath. Topic today is mocking frameworks considered harmful. And even after I submitted the talk, I figured out, well, you could read that in a couple of senses, and some of them I tried to list there. Is it mocking frameworks considered harmful? Or mocking frameworks considered harmful? Or mocking and frameworks considered harmful? By the way, for those who are not in the ISO C++ committee, what you see in the background is our campus and the beautiful town of Rapperswil in Switzerland. That's where next June's WG21 meeting will take place. So if you consider joining the standardization committee, that's actually one of the places to go to. The other one is Kona in Hawaii, where we had the meeting this spring. Now, as a professor, I always want to teach something to people, and considered harmful is something that has an ancient meaning in the programming era when people started writing about goto considered harmful. And usually it's something, a tool that you might overuse or use too much. We learned yesterday from Bjarne that goto is no longer something we use because it's so primitive. With mocking frameworks, I'm not really sure if the primitive argument actually is the right one. I'd like to show you when they are useful or when the mocking themselves is useful, and show you some means what's in there and what to look out for, and that's the idea of my talk today. And by the way, this hat, if you come next year to Rapperswil, I might provide another batch of these hats for those who come. Now, I usually ask my students questions about that. So my question is, who is using a mocking frameworks for writing automated tests? Who is refactoring their code often? Okay, let's see if let's say my musings share with your experiences, and I'm happy to learn otherwise in the end. A lot has been written about testing and other stuff, mainly targeting, or people from the, let's say, OO Java-ish community actually are exposed to these things. But the wisdom in these books, especially these two I'm referring to, is actually valuable for C++ people as well. So there's XUnit test patterns, and XUnit stands for all these famous unit testing frameworks, starting with SUnit for Smalltalk by Kent Beck, and JUnit by Kent and Eric Gamma, and all the others. We have plenty of those for C++ as well. And the good thing about these patterns is they are language agnostic most often, and they tell you something about the idea. And if you read any kind of pattern, always look for the fine print. It's not always, this is a great solution. A good pattern description gives you also hints about the drawbacks you have to pay for if you apply it. And that's some of the drawbacks that are actually explained in the XUnit test patterns in the very fine print I'd like to point out today. Another very interesting book that might also be underappreciated is Working Effectively with Legacy Code by Michael Feathers. And for him, legacy code is actually code that doesn't have enough tests. And code without tests is bad code. And when he says tests, he means automated tests. And his book is actually about how to get stuff under test. And that's where you might actually need and appreciate the mechanism of mocking. And what that is, let's go to that. I'm also referring to another article because that's where I stole the example I'm using today. It's by Martin Fowler, who's also writing a lot of stuff about agile OO design and so on. And he has an article about mocks aren't stubs. And I'm stealing his example, and deliberately, because I've seen talks about mocking frameworks that use this example, and I'm trying to elaborate on that. Anybody not knowing Martin Fowler by name? Good. So the He has an interesting example that's quite simple. He wants to test an order class that relies on a warehouse class for fulfilling the order. And if you consider that, it's completely unrealistic, except for the example that used a Talisker whiskey to get it from the warehouse, or a whole batch of Talisker whiskey bottles. And it has some interesting design deficiencies that I don't want to show you right now. And if you can't read the diagrams, I'm not sure if it's really eligible there. Doesn't matter. The intended behavior of the order object is, if you want to fill an order, it asks the warehouse, do you have enough stuff in there? And if yes, remove it from the warehouse and memorize that the order is filled. And it's kind of a stateful thing. If the inventory is not sufficient, it will just fail to fill the order. Now, if we just want to test the order class without a real warehouse that is delivering the Talisker, and if you run the test, you don't want to ship the 50 bottles of Talisker that you want to test for. So that's why you actually want to replace that warehouse object with a fake object that is actually doing nothing or pretending to be a real warehouse without doing anything useful. So you want to actually check the order class if it behaves like that, and you want to check if these interactions happen as you planned them. Now let's see what we can do about that. That's the underlying example that I stole from Martin. If you look at the X-unit patterns, there's a generic diagram that happens over and over again, and the basic idea is when you write a test case, you have something where you set up the tests, you exercise the methods of functionality that you want to check from the system under test, SUT, and then you verify if the test was fulfilled. That's where you actually have a test failure, and then you have the tear down phase where you actually clean up. In C++, that tear down phase is usually trivial. That's just a curly closing brace because we have destructors. And if you have to tear down something, the destructor will take care of that. For terminology, at least on my slides and in the X-unit patterns, SUT is a system under test. And the DOC is the dependent other component. In an ideal world, you can test this system under test without external dependencies. But if you come, like Michael Feather describes, from legacy code that doesn't have sufficient tests, you will actually end up with situations you have other components that you depend on. And now, how do you test that? You can test that on a system level, but if the other component is slow and, let's say, doing a database or communicating over a network, your tests will run slow and you will have very slow feedback, so you need to do something about that. And that gives you one of the situations why you want to actually do something about replacing that dependent other component by a replacement, and there are several words used for that: test stub, test or mock, or test double, and I might use them interchangeably, and I will give a little bit differencing what a mock is and actually what a stub is. So one thing is the real object that you're testing with, which is the dependent other component, not the system under test, has non-deterministic behavior. Like, how do you test something that relies on random number or relies on external input, like a stock market quote? The real object is difficult to set up. It might require network connections, database connections, or whatever. The real object your system under test depends on has hard to trigger behavior. How do you test for, let's say, file system failures or the log is full failures? The real object is slow, which is also something that's a problem, can be a problem, especially if you write software for real hardware. beyond just the chip it runs on, and like automotive or like other control stuff, then you need to have to do something about so that you be able to test your software fast and without actual hardware moving around. If your software still has bugs, you don't want to have the hardware, destroy the hardware from that. The real object has or is a user interface, or it's a user itself, herself or himself. And one thing where mocking actually is interesting about is the tests need to know if the real object is actually used correctly. For example, was a callback triggered or things like that. Or it doesn't yet exist. If you have a large system, you might want to write tests for a component that has to rely on some other components that are not yet implemented. And how do you do that? So the basic idea is actually that you replace this non-existent or missing or badly behaving other component by a so-called test double, a replacement. So you need a means to actually parameterize the system under test with a replacement component. That's hard to do if this one actually instantiates this other component based on a concrete class or uses it, like calling an operating system function that you need to replace because that might do I/O. So we want to avoid slow tests, and we want to actually be able to test this system under test. And only if we want to go to check if the system under test actually uses the other component correctly, that's when Gerard what Gerard calls mock object. And that's one of the aspects of Martin Fowler's article I was referring to. You want to actually check that the system under test uses this other component correctly, and you verify that in the end that it's used correctly. And that's where mocking comes in. So the setup actually needs to set up a replacement object, and this replacement object needs to verify if it's used correctly, either while it's used or in the end. And the verification step in our test case is actually doing something useful for the final verification. That is what mocking is about. For those of you who are using mocking frameworks, is that what you are actually doing? Some heads are going down, some waving. Okay. Now, many mocking frameworks actually provide you with something that Gerard calls the configurable test double. How do we tell a test double what to return and expect? And that's, in my opinion, is an idea that's quite often overused in the mocking frameworks that you encounter, because a lot of the mocking frameworks allow you actually to set expectations, return values, while configuring that test double or the mock. And then in the end, in the verification phase, the test double or some magic will actually check if the expectations have been met. And if you checking expectations is okay, but having everything spelling these things out, that's actually where the problems might come from. And I will give you some examples later on so you can appreciate my red blob there, what this means. So what do we actually get in a mocking framework? One thing is we need to provide something that people actually have many names for. One fancy name is dependency injection. And when you see that, you always think you get some kind of shot for immunization or whatever. It's not that magic. It's just provide a parameter to your object so you can actually replace what you pass in, instead of having hard-coded dependencies to concrete other stuff that are hard to replace. So what you actually would need to do is what Michael Feathers calls, you introduce a seam to make your system under test more testable by being able to replace the dependent other component. What a mocking framework usually then provides, very often the dependency injection is something you have to do yourself, or you might have tools for refactoring, and I'll show you some of them that we created for our IDE. And then the next thing is you actually have to replace the dependent other component. One example is just by a fake object that gives predefined canned results, so the system under test can be run without the real thing and provide something useful for the test case. If there's an interesting interface that you want to actually check if it's elaborated correctly between the system under test and the other component, then you might want to trace the calls while it's that the system under test does against the other component, the testable, and then you want to match if the calls and the arguments made on the other component that is replaced are correctly. And these are the core elements what go into a mocking framework, and that's what many people actually use. I've chosen 3 examples or 3 mocking frameworks. One is GMock because it's the most popular one and quite ancient one. Then another one that's a little bit more modern, C++ 14-ish, by Björn Fahler. And actually his talk at, I believe, ACCU or some other event actually triggered me giving this talk because trompe-l'oeil is a great framework, but using mocking frameworks easily makes code bad, and I'll show you that. And the third one is that actually one of my former students created in his master thesis. It's called Mockator, and it's integrated into our cvelop IDE. You might hear me speaking about in several occasions. Now the first thing is Michael Feathers tells us introducing a seam. So we have existing code and we want to make it better testable. So we actually need to do something about where we can alter the behavior of our system under test without editing the system under test because we want to test the real thing. There are several mechanisms that Michael actually presents. The classic OO-ish one is the so-called object seam. We extract an interface of our dependent other components and change our system under test to just use that interface instead of using a concrete component. And that's the thing that all mocking frameworks support, but not actually the extract interface. If you're using language like Java, where you have a very good refactoring infrastructure, it's almost automatic, so you don't have to do a lot editing. In other languages, you might need a little bit more things. cvelop provides some refactorings to get there, like extract interface refactoring. But again, you have to introduce a dynamic polymorphism to enable that, which is not always a good idea in C++ code. With C++, in contrast to Java, we have something that Michael Feathers calls compile seam, and we have a corresponding refactoring in the cvelop IDE, but you can do that by hand as well. You just make the other components type a template parameter and provide a default argument for the template parameter being the concrete other component, so you don't have to change the code base throughout. But then you can actually compile your system under test with a different template argument where you pass in the test tuple. And there, Michael also shows some more interesting seam things in cases that are more pathological, where you have dependencies on system libraries, or even more interesting things that are very hard to replace. And there are things of last resort where you can actually use a preprocessor to change a function name to something else where you can replace it, or you can use a linker or LD preload with a DLL to exchange system library functions to do so. And I won't go into those details because that's beyond what I want to show right now. So what we actually do is we want to use a zipper to be able to replace our warehouse object, our warehouse class. So what we actually need to do is extract an interface class. I called it iWarehouse. Write your unit, change the order that it's using the iWarehouse instead of the concrete warehouse class. The unit tests then will provide a mock or stub warehouse that is actually used for a specific test only instead of the concrete warehouse that might do actually the shipping to just this to test the order class. Anybody done things like that for testability? Okay, you're all experts. Why are you here? Now to show off a little bit, if we have a warehouse with some implementation and our order using that warehouse in the fill member function, what you can actually do, you can call the extract interface refactoring and it will actually extract the warehouse interface with pure virtual functions and make the warehouse just implement that interface, and it will also in the corresponding places of the order class change the warehouse to the warehouse interface. So these blue bars show what's actually changed or automatically generated by the refactoring. And you see it's a toy example, so in real world code you might have, let's say, slightly more interesting effects and it might not work completely automatically, so, but that's the idea. And you can do that by hand as well. For things, if you want to have a template extraction, we provide an extract template parameter refactoring. I don't show yet. And the interesting thing about templates, if you look back, here all member functions have to be given and they are generated as pure virtual because they might be used by order. And if you have do a replacement for that, you have to implement all of them. Because if it's pure virtual, you have to implement it. So with templates, that's a very nice feature. Only what is used needs to actually be provided by a template argument. And the compile theme refactoring actually will tell you, okay, if you see the mock warehouse is actually empty, if you look closely, it's a screenshot, and it will tell you, okay, you didn't implement all of the required member functions yet. And if you do that, it will actually create the missing member functions for you, but only those that have been actually called by the test case. So it does actually an analysis how order is implemented to figure out what needs to be provided by the mock warehouse. That's a cool thing, even if you want to change the code afterwards. Now, remember, we want to actually check if these calls are made from our replacement warehouse, and we want to test for that. So we write our test down here with an empty warehouse. We can generate that class, and again, we will be helped by the IDE or doing it by hand to add all the missing member functions that we need to implement, and these are completely auto-generated with default returns so that they will compile. And the nice thing, because the default return of a bool is false, and our empty warehouse, we expect the order not to be filled from, so our test case just runs. That's a very quick thing to go around our circle of writing the test, writing the code that fulfills the test, refactor, and write the test again. That was the case that you would apply if you do it by hand or with some support from your IDE. what would it look like with the mocking frameworks that I prepared for this talk? Most of the existings for C++ and the two examples I've chosen, gmock and trompe-l'oeil, requires you to use the extract interface with the pure virtual functions. And then, if you want to provide a mock, you have to use interesting macros to actually specify the overriders of the member function, and the macros will actually generate magic code for you so that the rest of the mocking frameworks can work with your mock warehouse objects. So for a const member function taking one parameter, you write mock const method 1 in gmock. Or in trompe-l'oeil, it's make const mock 1. So very close. That is one thing some people like. I hate it. Because it changes the language syntax. And as a tool builder, it's very hard to work with code that actually employs macros. If everything is fine, okay. But if you make a typo in one of the macro arguments, and you might consider, why do I need to write 1 and 2 here? Well, for the macro, it might not be able to recognize all the commas there correctly, depending on what you're using there. Like you might have a templated type with multiple template arguments, and the macro will just take the template comma as something interesting. Who has run into that with code? Yeah, that's a cool thing to debug. Especially the compiler error messages might be very interesting and very confusing, especially if you don't know that you have macro there. So I hate macros in C++ code, but a lot of mocking frameworks do that. So one of the considered harmful things that hurt. Now, if we just want to fake, and that means we want to provide a default result for our functions, replacement functions. If you do it yourself, the default for has inventory, for this case with the empty warehouse, it's returning false. With the mocking frameworks, we actually cannot just say return false. No. Many of those provide you with a specific infrastructure to actually specify how a function should behave. And in addition to that, they come with, as a side effect, not only specifying how it should behave, but also specifying how the system under test should actually call the object. The Google Mock people provide a macro called onCall, providing the object and the function and the arguments. And then you can say, okay, will by default return false, which reads nicely if you read English, but not that nicely if you want to read C++ code, because it's not C++-ish. Under the hood, they will build infrastructure to actually create an expression object that will be evaluated at runtime to provide the return of false. But it's not that obvious, and you have to learn the language and the right spelling. And the interesting thing, the Google Mock documentation actually tells us onCall is something that is underused. Many people write expect call. And I figured out why. OnCall, if you run your test cases and you use OnCall to just fake something, generates you a warning. It says, okay, you can just ignore it, but it nevertheless generates a warning. So you have the mental overhead of checking out, is that a real problem? Or is it just something that happens because I used OnCall? So if you're really want to work with a lot of tests and stuff, any warning actually triggers some bad feeling. So you better write your code and your tests so they don't trigger warnings, it just go green and pass. And that might be one of the reasons why on-call is underused. So many people over-specify saying, okay, we expect that this has inventory is actually called. And if the order object fill member function doesn't call has inventory with exact these parameters, exact these arguments, the test will fail. Trompe-l'oeil instead of expect call allows require call, but it also allows allow call, so it can actually specify the on-call a default behavior without actually requiring that the call is made. So if you refactor your fill member function doing something else and figuring out if the inventory is empty, it's still possible to do so without having the test fail. Now, we see here, we assert false order is filled, or in the other framework that I'm using down here, assert not order is filled. Where does the testing that the expectation actually happened is fulfilled happen? Well, it happens when the mock warehouse object, the warehouse here, is actually destroyed. So it's under stack unwinding, which is a little bit late, in my opinion. And that's one of the other problems many of the C++ mocking frameworks carry. They test stuff at destruction. If you have another problem where an exception is thrown, you might end up with interesting things because the checks are coming very late. So I already talked about the behavior verification by providing the expect call explanation. Sometimes you have interesting APIs here that you want to make sure that they help. The problem is if you specify a lot what should happen here, you over-specify the internal behavior of the system under test, so you might end up with fragile tests when you refactor your system under test that you're just evolving. And I have some better visualization for that. So if you want to fill a warehouse fill something from a full warehouse, we actually can say, okay, back to this, we first have to ask for has inventory. If that's true, we want to actually remove the Talisker 50 bottles from the warehouse. To do so, we again employ our expect call. With these arguments, we'll return true, and then we expect another call that it's actually removed. To make sure that these two calls are made in the correct order, first checking and then removing, we actually have to introduce magic by this in-sequence object in gmock to check out, okay, first this call and then that call, and it's by magic only because this in-sequence object happens to be there. These expect calls are actually checked in the sequence. And that's again magic on destruction of that in-sequence object that things like that happen. Trompe-l'oeil is a little bit more explicit. You also have this sequence object here, but you pass it into your require call, so it's more obvious that the sequence is required from these calls. But both frameworks suffer that the actual check that the calls have been made in that sequence is done here or here. But you have the check that the order is filled before. So if you have logic error that the order is not filled, even these calls are made, you might actually fail here and have multiple issues within a single test. And that's also bad about test cases. If a test case has multiple reasons to fail, it's very bad because you never know what went wrong immediately. You have to start debugging your test cases. Who is using the debugger to figure out if test cases are wrong? Ah, plenty. Go home, look into the mirror and say, I should write my test cases so that I don't need a debugger to figure out what's wrong. That's one thing to take home. No debugging. Core dumps are fine. We have a poster here that says core dumps are so retro. Core dumps are fine. Interactive debugging is the biggest time waster for developers. I get one thumb up. More, okay. And the other issue is many of these mocking frameworks provide you with their own language for specifying behavior. Well, we are programming C++. Why isn't C++ used for specifying the behavior? I give you some of the reasons later. Just to give you an overview, Trompe has a nice cheat sheet how it's to be used. And I don't want to explain the details. Go to Björn's talk or listen to one of his video recorded talks where he explains how great Trompe works. But just interesting thing, you write EQ, that's so Fortran-ish. Who remembers Fortran? It was .eq but nevertheless. Well, we have equals and other things. So interesting things. And because of implementation and language problems, there are things, oh, I have references or local stuff, I need to take care about that. Well, it's because magic happens in the destructor and your locals might be gone while you're checking things. That's a problem. Now, when we perceived Mocator with the tooling and the framework, I was thinking about Kent Beck, remembering he's saying, do the simplest thing that could possibly work. When in doubt. I figured out, is that really true? I remembered Kent saying it, but actually it was Ward Cunningham working with Kent saying, Kent, do the simplest thing that could possibly work when they were pair programming. For those, anybody not knowing who Ward Cunningham is, what he invented? Some of them. He's the inventor of the wiki web. Not Wikipedia but the wiki web. In 1992, I believe, or so. You can figure that out. So, what were my constraints? I hate macros. And I want just regular C++ code. And it was just after C++ 11 was available in regular compilers. So we provided, and we were writing against an IDE. So we have tools for generating and analyzing code, and that makes things simpler in my opinion. And those of you who still use, let's say, ancient IDEs or no IDEs at all, or an IDE called Emacs, I believe that's very retro, even more than core dumps. So what we provide is introduce theme refactorings for all kinds of themes Michael Feathers tells about. We generate regular C++ code that you can actually change and the stuff will still work. We generate regular C++ code for tracing calls, and that's where the simplest thing that could possibly work. We trace calls by just generating strings, or a little bit a slightly fancier mechanism for generating strings. And we use a vector with these call objects, with our strings, for tracing the calls, and you then just can compare the vector that is generated with the vector that you preset in the test case to figure out if there's a bug or not. So you set your expectations and it looks like that. You have a call to the constructor, you have a call to has inventory, and you call to remove. And these calls are actually happen in that sequence as you spell them out. You just assert equal the trace object with your expected calls, and if that's okay, everything is fine. If not, you get an interesting error message, and I show you in a second how that looks. And if you have more interesting stuff that should go on, if you want to check more interesting stuff, you still have the power of C++ and regex and your, let's say, interesting STL algorithms to figure out if the expectations are actually matched without learning any extra magic. And if you learn more about the details, there are nice screencasts made by my former student on mocator.com, and everything is available in cvelop. And if you try it out and find bugs, please tell us. We need our user feedback to improve. I just found a bug when preparing the slides, and it's already fixed by my assistant. So it's most of the time bug fixes are small, unless you have a big design problem, but that is also something that might happen from time to time. Just to give you an example, all this blue bar stuff is actually generated from cvelop, and then that's the example we've seen already. And if you have an expectation that is not met because we have our has inventory actually returns false, remove will not be called, and we see immediately in the diff view from our running test cases what's missing from the actual output. And that's very obvious to see, and that something is wrong. Either our expectation is wrong, which is in that case, or our implementation is wrong, which we could figure out then. And it's an assertion that's explicit in our test case. So we actually know what failed and where it failed, not at some kind of curly brace happening magic where things go wrong. Now, why is it as bad as I say, and why did I invent, together with Michael Rüegg, something different? Well, if you look for the history of mocking frameworks, they stem from a time of the mid-90s, late 90s Java code bases, where people started using JUnit, and other people invented JMock and EasyMock. And for example, Google Mock actually stems from the same designs. They even claim we descend from JMock and EasyMock. Java comes with built-in reflection. It only has classes and object, always has dynamic polymorphism, even if they tell something else, and it didn't have any lambdas then. So the only means to specify code pieces in the method was to invent some mechanism to easily specify code that is not code, because they didn't have lambdas, or not easy lambdas. Inner classes for everything, also not that nice in Java. So what happened, under the hood, the mocking frameworks provide subclassing with method implementation through reflection, and the lack of lambdas made them invent DSLs, domain-specific languages, to specify the behavior, and not just plain code. And the problem is, if you inherit a design because you think it's the best thing since sliced bread, without having the same constraints, you might end up with a design that's not just fitting. So, if you follow Java design in C++ code, bad. We don't have useful reflection yet in C++, so you might need macros for some stuff when you write unit testing frameworks, but you might not need that for defining stubs, but the mocking frameworks do so because they inherit that features from the Java frameworks. Relying only on virtual member functions, I remember an era when Google Mock and Google Test only worked with virtual member functions, nothing else, which is bad. It's not C++-ish anymore. Other mocking frameworks like HippoMocks do very low-level machine-specific ABI tricks like replacing virtual table entries, which is possible if you know how your compiler does your vtable layout, but it's also in the range of undefined behavior that is not really portable and might break with new versions of compilers. A lot of word goes into a DSL to specify, and that often also employs macro magic with implicit matching behavior instead of actual, and that in the structure of the magic objects that are generated from that. And it's very fragile, especially it's fragile with respect to refactoring, because refactoring tools cannot understand code like that. And it turns out that tests actually get bloated, because if you have, let's say, a more interesting interaction, like here a turtle object that's taken from the Google Mock documentation, you have quite a lot of things to figure out what's actually happening. So on the first call, get y will return 100, then it will return 200, and then it will stick at 300. And so what does that actually mean? There's also the curse of too much mocking. Because when I employ a mocking framework, when I check actually the internal workings, interworking of the system under test with the dependent other component, I write white box tests. White box tests actually make things frozen. Remember, white, ice, snow, frozen. Actually, ice is blue, but think of snow. It's hard to refactor for tools and manually, and a lot of design flexibility where you want to actually evolve your design and change your code is lost. It also fosters stateful APIs. Who is a fan of stateful APIs? Good. Like, okay, set this, set that, and then do it. One curse is many of the graphics frameworks inherit from Turtle graphics, which is inherently stateful. Who loves Cairo? Okay. GUI programmers or graphics programmers? Oh, okay. That explains a lot.
What do they have to mock?
I think I already told you that, just to make sure. Remember, if you use a mocking framework in a way like that, you have a lot of elaborated setup code, and you have that implicit checking of expectations actually after the verification call. And what happens then, you actually put super glue between your test case and the system under test, and between the system under test and the dependent other components. That's where the tight coupling, if you overuse mocking frameworks, comes from. Because you do this as a white box test, so you actually put the glue in, and you can no longer change what's happening within your system under test, which is not good. And it also means your test cases are so elaborate and long that you no longer appreciate changing them and simplifying them. And frozen code is bad, because your requirements will never be frozen. I skip musing on the stateful APIs. That's my Cairo example. Who can see on one simple glimpse what's happening there? It's very hard. And that's just example code from the Cairo documentation. Nothing fancy. Stateful APIs are bad. If you need sequencing, wrap things around, like nesting calls or nesting objects, and then you have sequencing implicit. When do I need actually checking the sequence? When you have an existing API that your system under test has to depend on, and that API is frozen and stateful, then it might make sense to employ a mocking framework to check if it's used correctly. One bad example that we have to live with is a classic C socket API. Who has written a C socket server socket? who was copying the code from the manual pages or some other source. Why? Because it's elaborate multiple steps that you have to do to actually get the connection. If you have another reason, tell me afterwards on Twitter or wherever. I think if you don't have an existing API, then don't employ mocking. You still might have to use faking, but don't mock. So, if you need to test legacy code, introduce themes, stop your dependent other components, and maybe mock it, but don't do it everywhere. Take the power of IDEs and C++, not macros and C-ish code or Java-ish code. And only if you have to test the code of APIs that are fixed and stateful, employ mocks so that are good. Be aware of the dangers and the power of mocking frameworks. They are like super glue fixing your design and code in a mean not that it's good, but that it's unchangeable, which is bad for code. It's called software for a reason. Do not use mocking frameworks liberally when you mock non-existing code, and keep it simple, or keep it stupidly simple, applies to test automation as well. Questions? And by the way, is anybody using Swift on a non-Mac OS? We are working on a Swift IDE for Linux called Tiffic. There's a question, please.
Google Mock has a nice feature, argument matchers. Is there an equivalent in Mockator?
If you want to do that, what you actually would do, let me show you a piece of code. What you would actually do, if you want to have a specific argument, it's traced here. So you can actually match that down here in your call.
Yes, but what if I want to have a wildcard? I don't care what are the values of the argument.
You just don't trace it here, because it goes into a string. You just don't put it in the string, and you don't put it in the string down there. So it's very simple. It's just strings. Or you put an underscore there if you really want to have the same look and feel. And it's C++ code. It's very obvious to see. That's just C++. That is just string concatenation. It's just a little bit of magic, so you don't have to do it manually for yourself. So it's very, very simple. Even simpler than you might have thought of. Other questions, please.
So I've been using this stuff for a couple of years now, and after you do it for a while, it becomes really apparent that none of this stuff has any first-class support from C++. And
I didn't get the beginning of your. Can you say it again?
So I've been using this stuff for quite a while. And
which stuff?
Mocking, unit testing, all that kind of stuff.
Okay.
And it becomes very obvious that there's no real first-class support in C++ to do this. A good example is the need to mark things virtual. Although you bring up the fact that Mockator probably doesn't have that same problem, but at least a lot of other frameworks definitely do.
Well, you can use templates for that.
Is there any, since you're on the committee, is there any work being done to actually provide decent support in C++ for unit testing and mocking? Like maybe actually part of the standard?
There is a lot of work going on currently on having decent reflection support at compile time within the library and language, but it still takes a couple of years to mature to actually being able to standardize it. But there are people working hard on that.
Yeah, because
it's just not simple.
Yeah, a lot of other languages have had this kind of stuff for years, so it's surprising.
Well, that's one of the reasons why we did that in the IDE, because it's very hard to be able to do it at with the compiler only.
Yeah. Okay, I'm just curious if there is anything going on.
But there are people who will actually tell you don't do reflection in C++ because the code gets too big. And that's true, because if you need all the stuff around at runtime, bad things might happen.
Yeah. Thank you.
Jeff?
I just wanted to update the record on one point, that Google Mock was the only framework where you didn't have a listed author. The main author of Google Mock is named Zhanyang Wan. He actually works in the Kirkland office a few miles from here.
I'm sure that,
and
I just couldn't figure it out
Yeah,
when I made that slide this morning.
When I noticed that, I checked. Our documentation doesn't credit him, and it really should.
It wasn't obvious, at least.
Yeah, so I'll see about fixing that. But just for the record, I think it's a really excellent piece of work.
Yeah. Sorry for that. One more?
Sure. So you mentioned the need for reflections to be able to write at least, decent mocking framework.
Unit testing framework.
Well, for mocking framework, I mean, if I look at something like an N substitute for C#, which is fantastic, of course they have like compile time and runtime reflection, and they can do all sorts of crazy things. I think with static reflection would be able to, have some templated class which can mock any virtual function of the template parameter class that you give it, and then you don't bloat the code, right? Because it's static reflection, it's not in the runtime. And then you could have a list of all the functions that you would want to mock in such a framework. So the question is similar to the previous question, right? So since we know that the committee is working on static reflection, is there anyone working on a mocking framework based on that proposal currently? And if not, why not? Because that would be my first use case for it.
It's also my use case for reflection in C++. The problem is it's not fleshed out yet exactly what should go in the standard. Mm-hmm. So there are slightly competing strategies how to achieve what you need for a static reflection. And the problem is it's a chicken and egg problem. So you don't want to commit with the mocking frame or with the testing framework without having the working implementation. Mm-hmm. And so you wouldn't be able to write tests, and you wouldn't want to change too much unless it's...
Right, but it would be a fantastic use case to help in the design of the specification.
There might be people who actually work on that, but I'm not aware. It's not on the, let's say, on the agenda of the standards committee yet.
Understand. Quick other question is, so all those IDE tricks that you're using in Cvelop, is that available in Eclipse as well? Or
it's available in our Eclipse-derived Cvelop. Right. And some of the stuff you might be able to install directly
as a plugin or something. Yeah.
Within Eclipse as a plugin. And if you're more interested, I have some flyers here. You can take them home and you can ask me.
All right, I'll do that. Thanks.
And if you tried and things fail, tell us. Please tell us.
Sure.
I'm not sure who was next.
Thanks. I really like you bringing the vector recording of calls to the forefront.
Thank you.
The reason being, vectors are regular if they're full of regular types, which means you can save the recording and then compare it to a trusted component recording it, so you don't have to hard code your calls. So if you have a component that works correctly, you can actually record the trace and then test an untrusted component with that trace.
Yes.
And no other framework actually allows you to do that. Because you can't just copy the damn thing. We should really have that in every mocking framework.
I would like to comment on the topic that you've the name of the presentation, which is mocking frameworks considered harmful. And from my personal experience, I was doing mocking a long time before I knew about mocking frameworks, and I found that when I actually started to use mocking frameworks, they limit my ability, because there's a specific language you need to know about, and there are only certain things you can do. It often limits the capability of a programmer to write as flexible tests as he would like. And sometimes it's much easier just to go and spend the time that it takes to spin off an interface and write a state machine within that interface, within the implementation, and then to do custom stuff, which maybe can't be expressed so easily with a macro or with a framework, because there you only have specific tools that you can actually use. And what I've seen is that people write very long, convoluted tests that don't really test much. They test trivial things like, I put in a variable and I want to see what comes out. And we all know that that works. What's really important is domain-specific behavior that is sometimes requires much more than just a simple macro or providing a delegate or a lambda, which are not stateful and are very difficult to emulate complex behavior. I wanted to hear what you think. What do you think about that? And do you think that's also an aspect of harmful behaviors in mocking frameworks?
Let's say if you do mocking by hand, that's good, because then you actually suffer from your bad design and you write real code that is easily, where you can see what it does and you can refactor it. Right. As you have observed, the mocking frameworks give you some handcuffs that look first very nice and interesting, but I hate it. And you seem to hate it as well.
Right.
And that's why I made this talk. And you should have spoken up before I started.
Okay.
So I had my complete motivation in your
okay, thank you.
contribution. And I think we run out of time. And I thank you very much. If you want to know more about Cvelop or whatever we are doing at our university, speak up to me. I'll be around until Friday morning and take some flyers.